a few parts to this no calculator problem there. Let me kind of just show my answers and work real quick first. There's a part D on another page there. And then we'll go through and we'll talk about each part quickly there. So for the first part, we've seen some stuff like this before with the slope field. You're just supposed to, it says, make sure you draw one that goes through the point 0, 0. So you have to go through the point 0, 0. So I basically just started there, say, hey, it's going up in that direction. So each little curve, it went up there and it went up there, and it's going in that direction, approaching that horizontal asymptote there. So if you have some questions, ask about those individually there, but you're just tracing that curve a little bit. And then for part B, it says using the correct units, interpret the meaning of the limit as t approaches infinity. So as you approach infinity, notice that it gets level and level and approaching this 12 problem right there that they gave us there. So that just means over time, the amount of medication in that patient is approaching 12 milligrams. All right, now letter C is what our strengths are. All right, this is where it's worth a big chunk of points there. It says using separation of variables, find the particular solution to the differential equation. So here's where we're going to integrate both sides. You have to separate your variables first, right? So you're going to multiply both sides by the dt, and then don't start integrating this stuff here. You have to make sure the y's are with the dy. So do legal algebra, divide both sides by the 12 minus y. The 1/3, it doesn't matter if you put the 3 there or you leave it as there. You're eventually going to have to solve for y anyways. So I always like to just leave the extra stuff on that side if I can. But even if you move the 3 over here, eventually you'll get the same answer anyhow, all right? So I got the y's with the dy, any other numbers or t's or numbers there with the dt. And now I can separate, now I have my variable separated, so now I can go ahead and integrate both sides there. When you integrate this side, that's your 1/3 t. We always put the plus c in the side the x's are on. When you're integrating this side, technically my u is the denominator. The du is equal to a -1. And then you have a 1 over u. So when you have 1 over a single letter, that's your ln. But since your du is a -1, you balance out with the negative right there. And what I always like to do, after I integrate it, put the plus c on there right away, and then use the initial condition. Use that 0.00. I like to plug in right away and get that c value because it's going to be worth more points if I could find that constant of integration properly, right? So I plugged in the 0 for the y, 0 for the t. That gave me c was equal to this -ln of 12. So then boom, I got some points with that. And then now it says y equals. So when you see that y equals, just for all the other problems we've done like this, you have to get the y by itself. So I plug in the constant of integration. And then what I like to do, since I have ln's on both sides, is I added that ln of 12 over here. And so I have my ln's now on both sides. I can use my pre-calc properties. I can do the ln of that over the ln of that, condense that stuff using your pre-calc properties, and then do your main definition of log, where you can go e to that equals that. So that brings us to right here. And then we're supposed to solve this for the y. So I can't solve that when it's in the denominator. So I multiply both sides by the denominator, and I divided both sides by the e to the 2/3, e to the t over 3, minus the 12 from both sides, divided both sides by a -1. And so you could have written this like the negative plus 12, that could have just flipped those around there. But since I divided by a -1, I just put the positive 12 first and then the -12 over at e to the t over 3 like that. All right, so trace the stuff, interpret that. Make sure you study that interpretation stuff right there, because we can get some easy points with those first two parts. And then you're practicing your integrals and stuff without the calculator right there. And then the last part of it gives us a bunch of words. All right, so sometimes these look more intimidating than they actually are right there. So I see this derivative thing there, and it says at time t equals 1 hour, there's 2.5 milligrams of medicine in the patient. It says, is the rate of change of the amount of medication in the patient decreasing or increasing or decreasing? Now, it doesn't say, is the amount of medication increasing or decreasing? It says, is the rate of change increasing or decreasing? When you see that word rate and that phrase rate of change, that is the derivative. They're asking, is the rate of change, is the derivative increasing or decreasing there? So if you want to know where anything is increasing and decreasing, if I say where is the amount increasing, if you want to know where anything is increasing and decreasing, it's where that derivative, its derivative is positive or negative right there. So since they're asking us, is the derivative increasing or decreasing, I got to find the second derivative and determine whether that's positive or negative right there, okay? If it says, is the amount of medication increasing or decreasing, that's when I'm plugging stuff into the first derivative and just seeing to determine if that's positive or negative right there. So that's just This stuff here you didn't really need. I basically just need this stuff here for my actual work there. But that I just kind of made a note for myself because that was kind of important. I could see some of us being confused over that. So I need to take the derivative of this guy. So the derivative of that is 0. And then I just got this negative y over t plus 2. And I just did my quotient rule. So I got the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Now, it says this is dy, just like your normal derivative is dy over dx. That's with respect to x, and we do our normal derivatives. But if I'm doing a dy dt, that means like the t is kind of like my x by there. So if I take the derivative of t's in here, that's just a normal derivative. But if I take the derivative of y's, that's where we got to tag on the dy dt, just like when we did our related rate problems. So I did my denominator times by the derivative of the numerator. So the derivative of negative y is just -1, but then you're tagging on the dy dt. And then I did minus my numerator times by the derivative of the denominator. Now, technically, you're tagging on the dt over dt, but that's just equal to 1. So like when you're doing the derivative of t's, that's just your normal derivative right there. Now, once I took that second derivative, I had to figure out whether at this particular point, whether that was positive or negative right there. So they tell us that t equals 1. So when t is equal to 1, they also tell us that there are 2.5 milligrams of medication. So at t equals 1, the y is 2.5. So I can plug in the 1 and the 2.5 for the t and the y, but then you also have this dy dt right there. And so they gave us the dy dt equation. So then I had to take the 1 and the 2.5, plug those into the first derivative equation, figure out that at that point, the dy dt was this 13 over 6 number. And so when I plugged it in, the negative was already there when I did my derivative. So then I had to plug it in and then just make sure you're practicing these without the calculator. You're actually practicing all the arithmetic on your own right there. But you kind of see my work there for the arithmetic, and I got that second derivative was negative. So since the second derivative is negative, that means the first derivative is decreasing. If the 35th derivative is negative, that means the 34th derivative graph is going to be decreasing there. So that's why I got the rate of change. That means that's the first order, the dy dt, the rate of change of that amount of medication is decreasing since that second derivative is negative. Bamboozle.